we gonna open the link or not?
What? Oh, I can open the link.
I do have the examples, but
Remember that if we take a homework,
do we have to open the links or?
No, I think that if you have like, the problem statement like this,
Okay.
you can just start saying the problem
Okay.
statement.
So for question 1, it's asking the first example in the YouTube video and which one is the regular singular point. And the answer is 2 and negative 2. And the example is wait. I haven't explained yet.
Okay, I'm sorry.
So the differential equation is a parenthesis x squared minus 4 parenthesis to the square times y plus 3 parenthesis x minus 2 parenthesis times y plus 5y is equal to 0. And we divide this by parenthesis x squared minus 4 parenthesis to the 2 to the power of 2, and we can put it in a standard form, and it's gonna be y plus a function of x times y and another function of x times y is equal to 0. And the first function of x is 3 to x minus 2 times x plus 2 to the square, and the second is just 5 to x minus 2 square times x plus 2 to the square. And to find the singular point, we have to look the denominator. We look where the denominators become 0, and we check the limits. If both of the limits are finite, then the point is regular singular point. So we just check x is equal to 2 and x is equal to negative 2, and this 2 satisfy with this condition. So the first question is just 2 and negative 2. The second question is asking in the first example, identify regular points, and at x is equal to as the point is negative infinite minus 2 negative 2. The second one, yeah, basically you got the answer. Yeah, it's already given in the YouTube video. And in the second example, where is the irregular singular point is x is equal to 0, the required limits does not exist. So that means the function is it is an irregular singular point at that point. So it's x is equal to 0. Yeah.
Okay. Question 4. In the first example, x equals minus 3 is, well, here the equation is x squared minus 9 to the power of 2 times y double prime plus x plus 3 in parentheses times y prime plus 2y equals 0. So first of all, we need to isolate y double prime, so I divide everything by parentheses x squared minus 9 to the power of 2. So that way I have a homogeneous linear differential equation. And when I get that, I try to factor and simplify each coefficient. So for y prime, I let the coefficient be px, and for y, I have the coefficient as qx. So then I need to find the limits as x approaches minus 3 for when I have x plus 3 times px, and the same if I get a number. That's the first check, and the second check is when I apply the limit as x approaches minus 3 of x plus 3 squared, so parentheses x plus 3 parentheses squared times qx. So applying both limits, I get a number, so I end up having that x equals minus 3 is a regular singular point. Well, the same process for when x is equals to 3. The same process of taking the limits when x, in this case x minus 3 times px, and then the same for x plus 3 parentheses squared times qx. And in that case, I have a limit that the answer is infinity, so that means it's an irregular singular point, basically. In the second example, I have a different equation, which is parentheses x to the power of 3 minus 2x squared plus 3x parentheses to the power of 2 times y double prime plus x times parentheses x minus 3 parentheses squared times y prime minus parentheses x plus 1 parentheses times y equals 0. So the first thing I need to do is to convert it into a homogeneous linear differential equation. So I need to like remove or cancel the coefficient in y double prime, and then I do the same process as the last two questions where I set px and qx, and then I take the limit as x approaches 0 in this case. And in this case, I end up getting real numbers for the answer when taking the limits when I have px and qx. So then this is x equals 0 is a regular singular point. And here this is basically true. There's not much explanation.